Hello, today we are going to discuss about transition from IPv4 to IPv6, how we are converting IPv4 addresses to the IPv6. So in this we will learn about the different transitions like dual stack transition, tunneling transition and the header translation transitions. So let's first discuss about the transition from why we need the transition from IPv4 to IPv6. As due to huge numbers of devices on internet, transition from IPv4 to IPv6 can't happen suddenly. So it takes time to convert every devices into the IPv6 addresses. So to make communication possible between every device in network, we need transition from IPv4 to IPv6. Now in internet system, some devices are working on IPv4 addresses and some are working on IPv6. So to make the communication between possible between these devices, we need transitions. So let's first discuss about this type of transition. The first is dual stack transition. So the in dual stack transition, a router or a host is equipped with both IPv4 and IPv6 addresses. It means the router which is equipped in the network knows about the IPv4 address and also about the IPv6 addresses. So in next slides, the shown example where the host from IPv4 as well as IPv6 can access the server with the help of a dual stack router. So the dual stack router can communicate with both the network. Using dual stack routers, we can also send and receive data belonging to both protocols simultaneously. It means the router which we equipped in the network knows both the protocols of IPv4 and IPv6 addresses. So the diagram shows that the network containing IPv6 address devices and IPv4 address devices are communicating and or accessing the server by using the same router. So the router which is connecting between these networks is equipped with both the addresses with IPv4 address as well as with IPv6 address. So they have a router know the both the protocols of IPv6 and IPv4. The next is tunneling transition. So in tunneling is a technique in which two computers using IPv6 addressing want to communicate with each other and the packet have to pass through a region of IPv4 addressing. So this means when two devices want to communicate knows the IPv6 address that they are working on IPv6 address and but the intermediate devices are working on IPv4. So to pass the packet through the IPv4 address region, so they must know about IPv4 address also. So to pass the packet through this region, it must contain IPv4 addresses. In this, when a packet enter the IPv4 region, IPv6 packet encapsulates in a IPv4 packet, and when it leaves that region, IPv6 packet exit from the IPv4 packet. So in this, the encapsulation of IPv6 packet is done in IPv4 addresses. So in such way, the IPv4 regions create a tunnel to pass the IPv6 packet, as shown in the example. The two devices which knows the IPv6 address wants to communicate, but the packet have to pass through the IPv4 network. So it must also know about the IPv4 protocols. So the tunnel is created between the two devices and the data and the packets are encapsulated while transmitting from IPv6 to the IPv4 network. So in this, a tunneling takes place. The next is header translation. In a network, when a transmitter device transmits a packet in IPv6 format and the receiver still works at IPv4 format, it means a device which wants to send the packet is working on IPv6 or knows the IPv6 addresses, but the receiver which have to receive the packet still working on the IPv4 addresses. It knows the protocol of IPv4 packet only address only. So then this tunneling technique will not work here. So here we will use header translation technique, in which header of IPv6 packet is converted to the IPv4 packet. So header translation devices are used to map address to translate IPv6 addresses to the IPv4 addresses. As shown in the example, the IPv6 host wants to communicate with IPv4 host. So a header translation device is used in between, which translates the header of IPv6 to the IPv4 or header of IPv4 to the IPv6. So this is all about transition from IPv4 to IPv6. Thank you.